This episode of Fluid Power Forum is sponsored by IFPE Motion Solutions Incorporated, the leader at engineering electronics into fluid power distribution. IFPE spans the 13 central states from Minnesota to Texas. For more information, visit ifpeusa.com.
The hydraulics tend, by their nature, tend to accept the abuse that they're subjected to. So, we definitely, certainly as Parker, we like hydraulics a lot
Right.
and know a lot about the technology, but they're still going to be needed because, they're still the best way to get the job done.
Welcome to Fluid Power Forum, a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, and it's my job to interview interesting people who are moving fluid power technology forward. As always, if you'd like to be part of our show, please follow us on Twitter. You can find us there at the NFPA. And on Twitter or other social media, make sure you're sharing those interesting and innovative uses of fluid power with our hashtag #OnlyFluidPowerCan. That is one of the ways that we source topics for our show. If you see an interesting application of fluid power and you want to learn more about it, you can share it on social media with that hashtag #OnlyFluidPowerCan. And you just might hear it discussed on a future episode of Fluid Power Forum. Also, please subscribe to our show. You can find us on Apple Podcasts, on Spotify. We're on most of the other major podcatching services. Wherever you find us, go ahead and subscribe and then give us a quick rating. Those ratings really do help promote the show and have more and more of our friends in the industry learn about us and join in on these important conversations. On today's show, our guest is Chris Griffin. Chris is a business development manager of Electrification for Parker Hannifin. And Parker is a diversified manufacturer of motion and control technologies and systems that provides precision engineered solutions for a wide variety of commercial, mobile, industrial, and aerospace markets. Parker is going to be exhibiting several of their hydraulic electric hybrid systems for implement control on mobile applications at IFPE, the upcoming International Fluid Power Exposition. And so we invited Chris into our forum today to learn more about some of those applications and the fluid power systems that make them all possible. So Chris, welcome to Fluid Power Forum.
Thanks, Eric. Glad to be here.
We're glad to have you on the show. I know our listeners, and I'm looking forward to the show coming up in March of 2023. We want to hear about some of the innovative products that Parker will have there. But before we go there, give our listeners a better introduction about yourself. What's your background? How did you find yourself doing what you do for a living?
Well, I've actually been with Parker my entire career. So it's been 27 years. Time marches on. That's not uncommon in Parker, but I've spent most of my career in what Parker calls electromechanical. Some people call it mechatronics. And until recently, I was the general manager of our North American electromechanical division. And that division, while primarily industrial, also developed a lot of the technologies that we're using now in vehicle electrification, especially motor technology and inverter technology. So, I've observed this gradual electrification of industrial markets over this long period of time. And I'm witnessing now a much faster transition in the mobile fluid power technology space in both on and off-road applications. So it's, it went quiet there for a few years, but the last 3 years have been pretty crazy.
It's been remarkable. Yeah. Go ahead.
Go ahead.
I was going to say it has been a remarkable trend to watch happen in the marketplace, and companies like Parker are kind of really on the cutting edge of some of those advancements, as you said. So your background, where did you go to school? What's your degree in?
I went to the University of Illinois at Urbana-Champaign.
Okay.
Big Ten person, and but yeah, I have a background in what's called general engineering. It's called, I believe, industrial systems engineering now, but back then that's what we called it.
And I always ask, when you were an undergrad and you were doing your engineering at Urbana-Champaign, was there any fluid power in your curriculum at that time? Were you exposed to it at all, or how did you first come across fluid power?
If it was in the curriculum, I don't remember it, to be honest. We did a lot of structures and dynamics calculations and some programming and drafting, but I don't specifically remember fluid power. I really was first exposed to it when I started working for Parker,
Yeah.
and more on the outside looking in. I was always involved in what we call automation technology, not so much hydraulics, although I do have some background in pneumatics as well. But
Sure.
I've just kind of observed it over the years. But more recently, especially in my new role, definitely it takes center stage in a lot of what we do.
Yeah, that's great. Yeah, you're not atypical. Don't worry. Lots and lots of engineers, unfortunately, still don't learn about fluid power in their undergraduate careers. But we're glad to have you in the industry and moving things forward. I talked a little bit about Parker Hannifin as a company in the introduction. What else would you want our listeners to know about Parker? It's almost a household name. I think most people are familiar with it, but
Yeah, I was going to say, I'm
yeah,
sure most of our listeners are familiar with Parker. Parker's been around for more than 100 years, based in Cleveland, as a lot of people know. And certainly it's a significant player in the global fluid power industry. We've got the hydraulic products, which we're very well known for, but also pneumatic, this electromechanical technologies, and then also fluid conveyance like hoses and fittings and products like that, which we're very well known for. But we're also active in sealing technology, filtration, climate control, and a big chunk of our business is actually focused on aerospace technology. And it's a lot of those industrial technologies that I talked about, but applied in the aerospace, in aerospace applications.
yeah, aerospace has been doing, the electrified, power unit for fluid power for a long time.
Yeah, certainly since I'd say the early 1980s,
Yeah, right.
early electrohydraulic, and now what we would call electromechanical as well,
Yeah.
on some of these airframes.
I remember a tour I did of one of Parker's aerospace factories out in California. Gee whiz, maybe 10 years ago, and my host was bragging and showing me a lot of those product lines at that point. So long history, if you will, in this kind of technology.
Yeah, for sure.
So I know the one product we definitely want to talk about and give people more information about is what you guys are calling your ePTO. PTO, I'm assuming, stands for power takeoff device, right?
It does.
Yeah. So
It's actually somewhat of a misleading term, because the PTO part's not really there in an ePTO, at least in most cases.
yeah,
But it's the term that the market identifies with, and PTO for power takeoff really refers to a mechanical device connected to the vehicle's transmission that
right,
takes off power,
right,
and then converts that into rotary motion to drive other systems. Usually a hydraulic pump, and that's basically your hydraulic power source to drive your body hydraulics.
yeah,
Whether it's a refuse truck or a dump truck or other types of utility vehicles.
right. Well, it's great that I asked that question because that's indicative of some of the innovation that's going on in the space. We don't know what to call these things sometimes, right? This whole hybridization of electric power source and hydraulic actuation, if I can say it that way, is really kind of blurring the lines between what's a pump and what's a motor and what's an actuator and what's a valve and all those kinds of things, right? So that's
Yeah,
really one of the
and
challenges.
we're having a lot of robust conversations within Parker, but also with our customers. I mean, you ask two people, you'll get four different answers as to what an ePTO is,
Right.
and but that's okay. We'll come to a consensus over time.
That's more of a marketing challenge. What are we going to call this
Yep.
thing exactly? So,
Yep.
so you mentioned just a few minutes ago there, some of the applications that this product would serve, if you will, and maybe we can recap some of those again, just to make sure that people understand, where they would find one of these things. So this is mainly for utility trucks, you said, or other large truck applications?
Yeah, I mean, the PTO in its, in the way we understand is typically found on what we call work trucks, but call it a utility truck, where
Okay.
basically you have a chassis that's provided by one of the large, OEM chassis manufacturers, and then a bodybuilder comes in and kind of adds a function to it. And that's where you get your refuse trucks, or you get, lifting trucks, aerial lift trucks,
Right.
dump trucks, things that are, doing some kind of work. But that's typically where we find them. But, there's also other types of applications on these vehicles that require a hydraulic power source. We're seeing people electrifying what we call auxiliary functions too, like steering systems, or compressors, or ventilator systems, and and those need to be driven by something, whether it's a hydraulic pump or directly driven by electric. So there are a lot of power needs on these vehicles, but PTO in this context is really about the the body hydraulics.
Yeah. And Chris, can you speak to the trends in that marketplace and kind of why things are electrifying? I mean, why is there the need for this particular innovation right now? What are you responding to in that marketplace?
Well, certainly we have a desire, whether it's driven by regional governments, whether it's driven by, commitments that companies make, and,
Mm-hmm.
Parker's made commitments about this too, reducing carbon emissions, right? And, different governments have different approaches, different carrots and sticks to get this done. But so, certainly the electrification of the PTO function is in part a way to reduce carbon emissions. Now, in, in a lot of these cases, there's still a diesel engine on the vehicle, right? But we're taking load off of that engine so we can reduce fuel consumption, allow it to operate at a more efficient, RPM and duty cycle. And, ultimately you can reduce wear and tear because a lot of these functions are either, belted off or tapped off of the transmission,
Mm-hmm.
and there's wear and tear associated with that. So what we're doing with the ePTO is we're basically taking that away and replacing it with a battery, an inverter, and a motor to then drive the pump, to drive the hydraulics.
Right. And the motor is running. So the battery is where the energy is stored, and then it's tapped when needed, or is that how it's configured?
Yeah, so you can plug you can charge the battery by plugging it into the mains power. You can also use the motor that is, part of the system can also be used as a generator as
Right.
well. So it could actually be attached to the diesel engine. So when it's not needed, it's actually operating as a generator and charging the battery too.
Yeah. Yeah. As I've talked with other people around the industry, it's like, what is that electric power source on a lot of these applications is really a fascinating discussion. Sometimes it's not one thing or another. There's a lot of different architectures that are being used. So,
Yeah, and, on a vehicle that's still got its internal combustion engine, it's
right.
typically a battery. But when we look at full battery electric vehicles, you have a much larger battery bank, and then we also have, manufacturers that are, looking at developing hydrogen fuel cell, technology to
Right.
ultimately charge the batteries as well. So there's different ways to get power. And, in some cases, they're also plugging it into the mains power too,
Right.
especially if it's a stationary application.
So this is, just to recap a little bit, this is partly in response to the need for reduced emissions in this market, right? That's what you were saying?
Yeah, and I focused on carbon emissions, but it's
Mm-hmm.
also a reduction of particulate emissions too.
Mm-hmm.
So things that that cause what we would think of as air pollution, but that's that's another byproduct of the internal combustion process. The other thing too is there are also regulations for engine off operation,
Mm-hmm.
particularly in urban or residential areas. You see it a lot, or you saw it initially in Europe, but you're seeing it in North America too. And these battery fed hydraulic systems can be run with the diesel engine off as
Right.
well. And they run a lot more quietly. They still make noise, but they do run a lot more quietly. And that allows them to do work maybe in an emergency situation or at night when it's quiet or cool,
Right.
and or there's not so much traffic. So those are other requirements that are driving the need to electrify these hydraulic functions.
So that's, as you said, they can run, you can still use the hydraulic actuation functions when the diesel engine's not running, essentially.
Correct.
Yeah.
Correct.
But and that's really then also speaks to the unique role that hydraulics still plays on these vehicles. A lot of times when people talk about electrifying mobile machines of one kind, they're left with the impression that we're losing the hydraulics, and that's clearly not the case in this case either, right?
Yeah, absolutely not. I mean, hydraulics are very force dense, and a lot of the work they do is tough. It's heavy loads, there's shock loads, they're operating in inhospitable environments, whether that's dust or dirt or high temperatures or low temperatures. The hydraulics tend, by their nature, tend to accept the abuse that they're subjected to. So, we definitely, certainly as Parker, we like hydraulics a lot,
Right.
and know a lot about the technology, but they're still going to be needed because they're still the best way to get the job done.
Yeah, absolutely. Well, yeah, I like hydraulics too, so it's important. It's kind of what we're all about at the podcast and at the NFPA. So yeah, it's as I said, it's an innovative trend that's going on, but the hydraulics is still going to be a big part of a lot of these machines going forward. And Chris, why don't we? I do want to talk obviously more about. That's a great background, if you will, in terms of the environment that we're finding these new products in, and we do want to talk more about the ePTO itself and learn a little bit more about that. But we've reached the point in our show where I have to take just a quick break here because I do want to make sure our listeners have the information they need about that trade show I mentioned earlier, IFPE, the International Fluid Power Exposition. IFPE is a place where you will learn everything that you need to help your company stay at the forefront of the mega trends that are affecting your business and industry. From sensor technology and data analytics to robotics and automation, you will see the latest innovations in fluid power that will help your machines and applications achieve your technology, performance, and business goals. At IFPE, you can have in-depth technical conversations with other engineers and other executives to spark new ideas. You can talk with suppliers about your specific challenges and the solutions that they offer. Or you can find new suppliers and new ways of doing things. Or even attend innovative education classes and sessions that cover the latest fluid power topics and industry trends, including college-level courses that provide professional development credit. No other trade show brings as many sectors of the fluid power, power transmission, and motion control industries together in one place. And this event happens only once every 3 years in conjunction with ConExpo ConAg, the largest international gathering place for the construction industries. Our next IFPE is going to be held March 14th through the 18th, 2023 in Las Vegas, Nevada. To learn more and to reserve your place, visit IFPE.com. All right, Chris, we're back from our break. And as I was saying beforehand, why don't we reset again on the device itself? You know, you gave a little bit of an overview at the beginning there about how it's made, you know, what the different pieces of it are. But recap that for us again. Help us understand what this product actually is.
So an ePTO is basically it's a battery-fed power source for hydraulics. So rather than tapping off of a transmission, although there in all electric vehicles there is a variant where you are tapping off the transmission, but that transmission is also driven by an electric motor. But I'm going to talk in the context of a separate system from either the diesel engine or from the traction system on an all-electric. So basically what you're talking about, you've got an inverter, you've got a motor, and you've got a pump. And those are working as a complete system. You may have some gearing in between the motor and the pump in order to allow the motor to run at a more efficient RPM. But at the end of the day, you're taking battery power and converting it into rotary motion at the motor, which is driving the pump. Depending on the vehicle, there could be variations of voltage. So if it's a diesel engine vehicle, very good chance it's a low voltage system, 24, 48 volts, maybe as high as 96. Although we are starting to see some higher voltage, 300 to 800 volts as well. Mm-hmm. If it's a full battery electric system, it's probably running off of a 300 to 800 volt system from the onset. With a diesel system, the ePTO is really separate, right? And that could be provided by the chassis manufacturer, or it could be provided by a third party or the bodybuilder as well. And we see different variations of that. Mm-hmm. When we're looking at all electric chassis, that's where we're waiting to see where the market goes. Now, we do have some instances where that third party can still provide the ePTO, but may have to provide their own battery. If the chassis manufacturer is providing the PTO, they're probably using the existing battery bank that's driving the traction and also using that to feed the PTO as well. So we see kind of different ways of doing it right now, but it hasn't fully shaken out that I've seen.
So that is something that you have to work with the truck manufacturer essentially to make sure that your product aligns with that architecture?
We work both with the bodybuilders who also have to work with those chassis manufacturers, and we're also working directly with chassis manufacturers. So some chassis manufacturers don't want third parties tapping off of their main battery system, so they want to control that aspect of it.
Right.
And some are a little bit more lenient with it. So it really depends on the relationship between the bodybuilder and the chassis manufacturer.
So it sounds like, is this then typically sold with the truck? I mean, the truck buyer gets this with the truck, or is this something additional that needs to be purchased?
Like I was saying before, depending on the relationship, we do have chassis manufacturers that are or will be selling an ePTO as an add-on to their chassis.
Okay.
So that's one way of doing it. And then, as I mentioned, there are situations where third parties can also offer basically completely separate battery systems that serve as an ePTO as well, but aren't necessarily fed by the chassis.
So it sounds like there's a variety of different configurations just within the ePTO itself that are very market and very application dependent, or even product line dependent, I guess.
Definitely, and also an ePTO may not even include the pump. It may just be the motor, and then the bodybuilder or the hydraulic system provider is determining what pump is going to be used to drive that system as
Okay.
well, based on, the design of their hydraulic system. So, it could be two components, it could be three. It really depends on the application parameters.
And it sounds like, working with someone like Parker then is a key component to that entire process to make sure that you've got the right ePTO that is interfacing between whatever the chassis or the truck manufacturer is putting on, as well as whatever the hydraulic application engineers are doing on the other side.
Yeah, I mean, certainly Parker knows a lot about the hydraulic system, and in a lot of these body hydraulics, we're providing the valves and the pumps and the hoses and fittings and cylinders, and so obviously we have a lot of the expertise, but we also have a lot of electric expertise. So
Yeah.
we've been selling a mobile focused permanent magnet AC motor. We call it the GVM series. We've been selling that for over 10 years. So we have a decade of application experience in putting electric systems onto vehicles as well. We have the inverter technology, and then obviously we can mate the motor and the pump. And depending on the application, you may want to use a different pump. Depending whether
Right.
it's efficiency, noise, cost, or compactness will kind of determine what pump you end up using as well.
Sure.
So, I think certainly Parker, I think, is in a great situation. We have expertise across the application, and then we also have control expertise as well. So we do mobile controls, so we can take things like pressure sensors and integrate that into the system, so we can create power on demand in a very efficient way by combining sort of all of the technologies that we can bring to bear.
Right. I want to talk about some of the advantages that this approach brings to the hydraulic system. We talked about the advantages in terms of efficiency and or emission reductions on the vehicle, but give us an idea, like just to ground us a little bit, like what kind of functions are we talking about? This is like lift trucks would be one example, right? Where you're lifting the bucket up to the telephone pole, or what other kind of examples would we have of what the hydraulics is doing?
Yeah, I mean, you could be looking at a refuse truck where you're,
Mhm.
you're tipping the dumpster, or you're doing the compacting. You could be, in a dump truck. Obviously, you're basically tipping the whole dump body. You mentioned the aerial lift truck as well.
Mhm.
And in a lot of cases, we actually don't change the hydraulic system too much. And especially if you're a bodybuilder where you're doing a mixture of traditional diesel-driven trucks and electric trucks, and there's some commonality there that really reduces complexity for you. So
Mhm.
we don't necessarily have to change the hydraulics. However, it's definitely something that needs to be looked at, because with battery technology, whether it's a separate battery just to drive the PTO circuit, or if you're using the chassis battery, you know even one or 2 points of efficiency gain have a significant impact on the performance of the battery, and probably more importantly, the cost of the battery. So,
Mhm.
what we're seeing right now is kind of phase one. A lot of the OEMs or the bodybuilders would basically, either remove or downsize the diesel engine, put the electric motor in there, driving the pump, and that was phase one. Phase two is really, okay, let's start to optimize the hydraulic system. Let's look at, do I need to have a single pump driving all the hydraulics, or should I decentralize it and have multiple pumps or multiple motors and pumps, so that I
Mhm.
can provide power on demand where it counts, and reduce, overproduction of flow, things like that. Um, so, and then the third phase, which we're not quite there, we're starting to see it with some of the larger OEMs, is where they kind of take a clean sheet approach and, kind of rebuild the foundation of the hydraulic circuit, still using the hydraulics, but maybe taking a new approach as they look at a fully electric system that's providing the power.
Right. I mean, I know the power delivery, if I can call it that, coming from an electric source, whether it's a battery, is is different than what you would get off an internal combustion engine. So that has ramifications for how the hydraulic system is configured and how it can operate efficiently.
Yeah, and typically these hydraulic systems that are driven by a mechanical PTO, they're kind of the least efficient thing on the vehicle, right?
Right.
There's been decades of technology and development put into to making internal combustion engines efficient, but the hydraulics haven't had to be efficient because there's lots of diesel fuel. It only takes a few minutes to fill it back up. It's relatively inexpensive, although maybe not so much today.
Right.
So it was kind of considered a free power source, right? But with a battery, it's not a free power source. It's a very expensive power source. And to recharge it, if you're not able to swap batteries out, it takes time.
Right.
It doesn't take a few minutes. It could take 2 hours. So it's a very precious commodity. And, as we look forward, we have to look at designing the hydraulic systems to minimize the usage of the battery power.
Right, and so the ePTO is part of that equation, right? It's helping to deliver the flow or the power most efficiently from the battery source. What other kinds of things are you then needing to do with the actuation system, if I can call it that, the hydraulic system that's attached to the PTO in order to maximize some of those benefits?
Well, some of the things that we can do, as I mentioned before, is you could decentralize the system somewhat. So the simplest form is where you have a single source of pressure and flow, and you're actuating the different axes through control valves, and you may be producing flow when you don't really need it. But if you decentralize some of those systems, and maybe you have two motors and pumps, and one of them drives two axes, and a third one drives a really special axis, and maybe that special axis it takes advantage of gravity lending a hand, and you can do energy recovery through that system as well.
Uh-huh.
So, these are some of the ways that you can kind of configure the system to only consume power when it's absolutely needed.
And you were saying that those kinds of innovations are kind of what you said was phase 3 of your process, right? So that's kind
It's a bit of phase 2 and phase 3.
All right.
We're starting to, as we engage with OEMs, and we've got an applications team that's focused on these electrification technologies, and we're working on projects right now where we are kind of stepping back, taking a clean sheet of paper, and making recommendations to say, hey,
yeah.
If you change your system this way, you're going to get this increase in efficiency, and ultimately this increase of hours on the battery, for example.
Right.
And that's something that customers certainly take note of.
Well, a lot of that exchange of information between customers and suppliers, the trade show is a unique place where some of that stuff can happen. It's interesting for people to go through the hall and actually see the products and talk directly with the engineers. When listeners go to IFPE and they visit the Parker booth, what relative to this ePTO, what are they going to be able to see there? Can you describe for us what your plans are for the show?
Yeah, sure. You'll see examples of ePTOs. You'll also see some of the components. So we've got some, inverter technology, both low voltage and high voltage. You'll see the motor technology, and then what we call configured e-pumps, where you're taking, these vehicle electrification focused motors and matching them with hydraulic pumps. Where it's a very efficient coupling design, and we've actually taken the time and the effort to actually test and characterize the performance of each of these systems, so that the customer can maybe not just pick it out of a catalog, but certainly have the guidance to say, hey, if this is what you're looking for, whether it's high efficiency, low noise, reduced cost, reduced complexity, here are some of the different combinations that we can offer. And by the way, here's the performance curve to tell you what that combination can do for you.
Right. Are there other things you'd like our listeners to know about Parker's appearance at IFPE? Are there things that they should be looking for?
Well, there certainly will be some engineers there who have been very active in these applications. So, you'll be able to talk to people who have done some really innovative things in this space. And certainly I invite listeners who are attending the show to definitely take advantage of that. So we've got resources dedicated specifically to the electrification of hydraulics in the mobile space.
Right.
They're not just hydraulics folks. They are, it's a combination of electric technology and hydraulic technology. and they're gaining experience with each passing month, and with each successful application that we help a customer bring to the market.
Yeah. It really is an exciting time, as we were saying earlier, to be part of this market and this industry, and I know we're looking forward to the show to have a lot of those interactions take place.
Yep.
Absolutely. All right. Well, Chris, I appreciate your time on the show today, and that is going to wrap things up for this episode of Fluid Power Forum. I want to give my thanks to Chris Griffin of Parker Hannifin, who has been my guest. If you'd like to connect with him, we're going to put his email address in the show notes to this episode. I know he would welcome anyone to reach out who wants to learn more about the products or services that we've discussed on the show. And remember, to learn more about fluid power generally, your best bet is to attend that IFPE trade show. You can see firsthand the latest fluid power technology advancements and learn from industry experts. Visit IFPE.com for more information about that show in March of 2023. And remember to keep following our podcast. You can find us on Twitter at the NFPA, and use that hashtag #OnlyFluidPowerCan to highlight the interesting and innovative applications that you'd like to learn more about in the fluid power industry. Fluid Power Forum is a podcast of the National Fluid Power Association. I'm your host, Eric Lanke, reminding you to join us next time in the forum.